Imagine this. It's the year 2500. A massive spacecraft the size of a city drifts silently through the interstellar void. Its hull glows faintly, absorbing the dim light of a distant, unknown star. Inside, thousands of humans live, work, and dream, far beyond the boundaries of the solar system they once called home. The descendants of Earth have finally broken free from their cradle, embarking on the greatest journey in history, the voyage beyond the stars. But will this vision ever become a reality? Could human beings, fragile creatures of flesh and bone, ever truly leave our solar system behind and become an interstellar species? Or will we forever be trapped in orbit around our one and only sun, doomed to watch the stars from afar without ever touching them? At first glance, the challenge seems insurmountable. Space isn't just big, it's beyond comprehension. Right. Now the farthest human-made object from Earth is Voyager 1, a spacecraft launched in 1977. After traveling through the cosmos for nearly 50 years, it has finally crossed into interstellar space, beyond the influence of our sun's solar wind. But even at its incredible speed of over 38,000 miles per hour, it would take Voyager 1 more than 75,000 years to reach the nearest star, Proxima Centauri. 75,000 years. To put that in perspective, 75,000 years ago, early humans were still battling the Ice Age, living in caves and coexisting with Neanderthals. If we had launched a spacecraft back then, it still wouldn't have arrived at the closest star today. This is the fundamental problem with interstellar travel. The sheer scale of space is staggering. Consider this: our galaxy, the Milky Way, is over 100,000 light-years across. Even at the speed of light, an unimaginable 670 million miles per hour, it would take a full 4 years just to reach Proxima Centauri. And at our current speeds, we may as well be standing still. The distances are so vast that they challenge our very understanding of time, making journeys between stars seem less like a scientific problem and more like a question of human endurance across generations. So what's stopping us from traveling faster? The answer lies in the very physics that govern our universe. Traditional rocket engines, the kind that carried Apollo astronauts to the moon and launched rovers to Mars, rely on chemical propulsion. These rockets burn fuel to create thrust, an incredibly effective method for short distances. But when you're talking about interstellar travel, chemical rockets are laughably inadequate. Even the most powerful rocket ever built, NASA's Space Launch System, could never carry enough fuel to reach another star in a human lifetime. The problem is simple. The faster you want to go, the more fuel you need. But the more fuel you carry, the heavier your spacecraft becomes. This creates a vicious cycle where the energy needed to propel a spacecraft forward increases exponentially with speed. To escape this trap, scientists have been exploring alternative propulsion methods, ones that could, in theory, allow us to reach another star within a single human lifetime. One of the most promising concepts is the light sail, a spacecraft that doesn't rely on fuel at all, but instead rides on beams of light. The idea is simple, yet revolutionary. An ultra-thin, highly reflective sail could be pushed by powerful lasers fired from Earth. This method, known as photon propulsion, could accelerate a spacecraft to extraordinary speeds, reaching up to 20% the speed of light. That's fast enough to reach Alpha Centauri, the closest star system, in just 20 years. A project called Breakthrough Starshot is already working on this, aiming to send tiny gram-sized probes to Alpha Centauri at unprecedented speeds. If successful, this could be humanity's first step toward interstellar travel. But there's a catch. This technology is still in its infancy, and scaling it up for human travel presents enormous challenges. The amount of laser energy required to propel a full-size spacecraft would be immense, and keeping a delicate sail intact while moving at such speeds through interstellar dust is an unsolved problem. Another idea is nuclear propulsion, which could harness the energy of atomic reactions to drive a spacecraft at speeds far beyond chemical rockets. One of the boldest proposals from the 1960s was Project Orion, which suggested propelling a spacecraft by detonating nuclear bombs behind it, using the explosions to push it forward. While this could, in theory, allow us to reach a fraction of the speed of light, the idea comes with obvious drawbacks. Detonating nuclear bombs in space is not only dangerous, but also politically and logistically complicated. More recently, scientists have explored fusion propulsion, which would use the same process that powers the sun to drive a spacecraft forward. If we could build a working fusion engine, we could reach speeds of 10 to 20% the speed of light, making interstellar travel within a human lifetime a real possibility. However, as of today, practical nuclear fusion, whether for power plants on Earth or spacecraft propulsion, remains just beyond our reach. And then, there's the most exotic idea of all: warp drives. If we could manipulate space itself, bending and warping it like a wave, we could theoretically travel faster than light without breaking the laws of physics. This idea was first proposed in the 1990s by physicist Miguel Alcubierre, who suggested that a spacecraft could ride on a bubble of warped space-time, compressing space in front of it and expanding space behind it. This would allow the ship to effectively move without violating Einstein's laws of relativity. The problem? The energy required to make this work is astronomical, potentially more than the mass energy of an entire planet. Right now, warp drives exist only in theoretical physics and science fiction. But as history has shown us, what seems impossible today could one day become reality. So where does this leave us? The dream of interstellar travel is still just that, a dream. But dreams have a habit of becoming real. Less than a century ago, the idea of walking on the moon was pure fantasy. Today, it's history. The question isn't just whether we can leave the solar system, it's whether we will. If human curiosity has proven anything, it's that we never stop pushing boundaries. The very fact that we're discussing interstellar travel today means that someday someone will take the first step. But how? What projects, breakthroughs, and daring missions could actually take us beyond our solar system? And when might this happen? In the next section, we'll explore the boldest ideas that could one day turn science fiction into reality. Picture this. It's the year 2100. A new spacecraft, unlike anything humanity has ever built, sits on the launch pad. It's sleek, immense, and unlike the chemical rockets of the past, it doesn't need massive fuel tanks or explosive propellants. Instead, it hums with an energy source so advanced that it could propel us beyond our solar system within a single lifetime. As the countdown begins, scientists, engineers, and billions watching from Earth hold their breath, because this isn't just another space launch. This is the moment humanity reaches for the stars. But how would we get there? What kind of technology could allow humans to break free from the sun's gravitational hold and travel to another star system? The answer lies in a combination of innovation, scientific breakthroughs, and sheer human ambition. The first step is to build a spacecraft that can travel far faster than anything we've ever imagined. Let's talk about nuclear fusion propulsion, one of the most promising technologies that could turn interstellar travel into reality. Unlike traditional chemical rockets, which burn fuel to create thrust, fusion propulsion would harness the same energy that powers the sun, nuclear fusion. Inside the sun's core, hydrogen atoms collide with such immense force that they fuse together, releasing enormous amounts of energy. If we could replicate this process in a controlled way, we could create propulsion systems capable of reaching speeds of 10 to 20% the speed of light. That means a journey to Proxima Centauri wouldn't take thousands of years. It could take just 20 to 40 years. But building a fusion-powered spacecraft is easier said than done. While scientists on Earth have been working for decades to create practical nuclear fusion reactors, the technology is still in development. Current designs require extreme temperatures, over 100 million degrees Celsius, to achieve fusion, and sustaining it long enough to generate usable energy is a challenge. However, proposed designs like the direct fusion drive, DFD, developed at Princeton, suggest that small, efficient fusion engines could one day propel spacecraft much faster than today's rockets. If successful, this could be our best bet for reaching the stars within a reasonable time frame. But let's say we push beyond fusion propulsion. What if we could build a spacecraft that didn't carry fuel at all? This is where laser propulsion comes into play. Instead of relying on an onboard energy source, a light sail could be propelled by incredibly powerful laser beams fired from Earth or space. Imagine a spacecraft equipped with an ultra-thin mirror-like sail, catching the intense pressure of focused laser light and accelerating to incredible speeds. The Breakthrough Starshot initiative is already testing this concept on a small scale, aiming to send tiny gram-sized probes to Alpha Centauri at 20% the speed of light. But scaling this up for human missions presents enormous challenges. The laser array needed to push a full-size spacecraft would require gigawatts of energy, far more than anything we can currently produce. And even if we could solve that problem, the ship would need a way to slow down once it reached its destination, or else it would shoot past its target at an uncontrollable speed. That brings us to another groundbreaking idea: antimatter propulsion. Antimatter is the most powerful energy source known to physics. When a particle of antimatter meets a particle of matter, they annihilate each other completely, releasing pure energy. Just 1 gram of antimatter contains as much energy as an atomic bomb. If we could harness antimatter in a controlled way, we could create a propulsion system capable of accelerating a spacecraft to speeds approaching half the speed of light, cutting interstellar travel time down to mere decades. The problem? Antimatter is extremely difficult and expensive to produce. Right now, we can only create antimatter in tiny amounts using particle accelerators, and storing it safely remains a massive challenge. But if future advancements allow us to produce and contain antimatter efficiently, it could become the ultimate fuel for interstellar travel. And then, there's the wildest possibility of all: warp drives. This isn't just science fiction, at least not entirely. The Alcubierre drive, a theoretical concept proposed by physicist Miguel Alcubierre in 1994, suggests that faster-than-light travel might be possible without violating the laws of physics. Instead of moving through space, a warp drive would bend space-time itself, contracting space in front of the ship and expanding it behind. This would allow the spacecraft to effectively ride a wave of warped space-time, reaching its destination faster than light without actually moving faster than light. The problem? The energy required to create a warp bubble is mind-boggling, potentially requiring more energy than exists in the entire observable universe. However, recent research has suggested that small-scale warping of space might be possible, reigniting hope that warp technology could one day become feasible. So where does this leave us? Right now, the most realistic path to interstellar travel lies with fusion propulsion or laser-driven light sails. Both of these methods could, in theory, carry a human crew to another star within a single lifetime. But there's another problem: survival in deep space. Even if we develop the perfect propulsion system, humans will have to endure years, or even decades, of isolation, cosmic radiation, and psychological strain. We'll need to build self-sustaining habitats, advanced life support systems, and even ways to artificially slow down aging so that astronauts can survive the journey. One possible solution? Generation ships, massive spacecraft designed to carry entire communities where people would live and die over multiple generations before their descendants finally reach a distant star. Another possibility: suspended animation, a way to place humans in a hibernation-like state for years or even centuries. Research into cryogenic sleep is already underway, and while we haven't yet figured out how to safely put humans into long-term stasis, breakthroughs in this field could be a game-changer. The road ahead is filled with challenges, but if history has taught us anything, it's that humans never stop pushing boundaries. The dream of interstellar travel is no longer just a fantasy. It's a real scientific pursuit, one that could change the course of our species forever. The first steps are already happening in research labs and space agencies across the world. The question is not if we will go, but when. But before we set sail for the stars, we have to ask, why? Why should humanity even attempt such an impossible feat? What's out there waiting for us? In the next section, we'll dive into the greatest mysteries of the universe, what we might find beyond our solar system, and why the survival of our species might depend on becoming an interstellar civilization. Imagine standing on the bridge of a starship, looking out at a view no human has ever seen before. The familiar glow of our sun is long gone, just another distant speck among billions. Ahead of you lies a new world, one orbiting an alien star, with landscapes sculpted by forces beyond our comprehension. Towering mountains of diamond, endless oceans of liquid methane, skies painted in colors our minds can barely process. The ship's sensors hum, collecting data, and a single thought fills your mind: we did it. We left the solar system. But why? Why would humanity go through the unimaginable struggle of traveling across the void of space to reach another star? What drives us to dream beyond our own cosmic shores? For some, the answer is simple: survival. Right now, we live on a single fragile planet, orbiting a single star. All it would take is one catastrophic event, a supervolcanic eruption, a massive asteroid impact, or a gamma-ray burst from a dying star to wipe us out in an instant. And even if we survive these immediate threats, the slow march of time guarantees that our sun will one day expand into a red giant, swallowing Mercury, Venus, and possibly even Earth itself. If humanity wants to survive long-term, we must become an interstellar species. But survival isn't the only reason to leave the solar system. There's something deeper, something written into our very DNA. Curiosity, the same drive that pushed our ancestors to cross vast oceans on Earth, to explore the depths of the unknown, to reach the moon, and to send probes to the edges of our solar system. That same force is pushing us now toward the stars. And out there, in the depths of space, we may not be alone. Consider this. The Milky Way contains over 400 billion stars. Scientists estimate that at least 1 in 5 of those stars has an Earth-like planet in the habitable zone, the region where liquid water can exist. That means there could be billions of potentially life-supporting planets in our galaxy alone. And that's just in the Milky Way. The observable universe contains 2 trillion galaxies, each filled with hundreds of billions of stars. The sheer numbers are staggering. If life arose on Earth, it must have arisen elsewhere, right? This question, are we alone, has driven scientists for centuries. We've scanned the skies with telescopes, listened for radio signals from alien civilizations, and sent our own messages into the void. But so far nothing. No signals, no beacons, no undeniable proof of extraterrestrial intelligence. This is the Fermi Paradox, the great silence. If the universe is so vast and if life is so common, then where is everyone? One possibility is that intelligent civilizations are out there, but they're simply too far away for us to detect. Space is incomprehensibly vast, and radio signals weaken over distance. Even if another civilization sent a message our way, it might take thousands of years to reach us, or we might have already missed it. Another chilling theory is that civilizations don't last long enough to communicate. The Great Filter Hypothesis suggests that somewhere along the path from simple life to advanced interstellar civilization, there's a nearly impassable barrier. Maybe most planets never develop life at all. Maybe intelligent life almost always destroys itself through nuclear war, environmental collapse, or something we can't even imagine. If that's true, then perhaps we are alone. Or perhaps we're next. But what if the opposite is true? What if something is out there watching? Some scientists believe that advanced civilizations might be deliberately avoiding us. This idea is called the zoo hypothesis, the notion that we're being observed but not interfered with, like animals in a nature preserve. Maybe we're too primitive to contact. Maybe they're waiting for us to pass some cosmic test before making themselves known. Or maybe there's a far more terrifying answer. The dark forest hypothesis suggests that the universe is a dangerous place, filled with civilizations that stay silent for their own survival. In this scenario, any species that broadcasts its existence runs the risk of attracting the wrong kind of attention. Imagine a vast, silent forest where every creature is a hunter, and the only rule is stay hidden or be hunted. If this is true, then sending signals into space, like we have with the Voyager probes and radio telescopes, might be the greatest gamble humanity has ever taken. So what happens if we do find life? If we reach another star system and discover alien organisms, whether microbes in an underground ocean, towering trees in an alien jungle, or even intelligent beings with their own civilizations, how would we react, and how would they react to us? If history is any guide, first contact would be complicated. When European explorers arrived in the Americas, the results were devastating for the indigenous civilizations. Diseases, war, and cultural clashes reshaped the world forever. If we encounter intelligent alien life, the consequences could be even more unpredictable. Would they welcome us as fellow explorers, or see us as a threat? Would we be the explorers, or the colonizers? But maybe, just maybe, first contact could be humanity's greatest moment. A chance to learn, to exchange ideas, to finally answer the greatest question of all. Are we alone in the universe? One thing is certain. If we want to find out, we must go. We must push beyond the boundaries of our solar system and step into the vast, uncharted dark. The technology is coming. The will is there. The only question left is, when? In the final section, we'll explore what's next. How close are we to taking the first real step toward interstellar travel? What challenges remain? And what can you do to be a part of this future? The year is 2147. A spacecraft unlike anything in human history drifts silently between the stars. It left Earth decades ago, carrying the hopes of an entire civilization. The crew, whether flesh and blood, digital consciousness, or something beyond our understanding, awakens from a long sleep. They step forward, gazing out at a distant alien sun and the world that orbits it. A planet that perhaps no longer belongs to the realm of the unknown. This isn't science fiction. It's a future that, if we choose, we can make real. But where do we stand today? What will it take for us to finally step beyond our solar system and into the vast ocean of interstellar space? Right now, our fastest spacecraft, Voyager 1, is traveling at 38,000 miles per hour. Even at that speed, it would take 70,000 years to reach the nearest star. That's an impossible timescale for human travel. If we want to become an interstellar species, we need speed, and that means revolutionary propulsion systems, new materials, and breakthroughs in physics. We've already discussed fusion propulsion, laser sails, and even the possibility of warp drives. But what's happening right now? Who is actively working on making these dreams a reality? One of the most promising initiatives is Breakthrough Starshot, a project backed by renowned scientists like Stephen Hawking and billionaire Yuri Milner. Their goal? To launch a fleet of tiny, ultralight probes, each equipped with a thin, reflective sail. By firing powerful Earth-based lasers at these sails, the probes could be accelerated to 20% the speed of light, reaching Proxima Centauri in just 20 years. The first test flights are already in development. If successful, this could be the first real step toward interstellar exploration. Meanwhile, at NASA, scientists are working on the Heliopause Electrostatic Rapid Transit System, HERTS, a concept that uses charged wires to harness the power of the sun's own particles, allowing spacecraft to slowly build up speed and escape the solar system without the need for fuel. The goal? To send a probe beyond the sun's influence within a fraction of the time it took Voyager. And then there's the DARPA and NASA-funded Draco project, a nuclear thermal propulsion system designed to dramatically cut down travel time within our own solar system. While it won't take us to another star, it could be the stepping stone to interstellar flight, making missions to Mars and beyond much faster. But propulsion is just one piece of the puzzle. The second challenge: building. A ship that can sustain human life for decades, or even centuries. A journey to another star is not a weekend trip. Even with advanced propulsion, human crews would spend years, possibly entire lifetimes, on the voyage. That means developing closed-loop life support systems where food, water, and oxygen are endlessly recycled. It means solving the problem of radiation exposure, which in deep space is hundreds of times more dangerous than on Earth. And it means preparing the human mind for the psychological toll of extreme isolation. One possible solution: generation ships. Instead of sending one crew, we could send entire communities, self-sustaining, spaceborne societies, where multiple generations would live and die before their descendants finally reach a new world. But this raises profound ethical questions. Would it be right to send people on a voyage they never agreed to? Could a civilization survive in complete isolation for hundreds of years? Another idea: suspended animation. If we could place astronauts into a deep, controlled hibernation, slowing their metabolism to a crawl, they could survive the journey without aging, waking up only when they arrive at their destination. While this may sound like science fiction, researchers are already studying ways to induce torpor in humans, inspired by animals like bears and Arctic ground squirrels. If perfected, this could be one of the most practical ways to send humans across the stars. And then there's the ultimate solution. What if we don't send humans in the way we imagine today? Some scientists believe that by the time we're ready for interstellar travel, we won't need physical bodies at all. Advances in artificial intelligence, neural uploading, and cybernetics could allow us to transfer human consciousness into machines. Instead of fragile biological beings, we could become digital explorers, beings of pure information, traveling as data beams across the galaxy, ready to be reassembled in robotic bodies at our destination. This wouldn't just solve the problem of long-duration space travel, it could redefine what it means to be human. So, will humans ever leave the solar system? The answer is yes, if we choose to. The science is advancing, the ambition is there. But the biggest challenge is not technology, it's commitment. Throughout history, every great journey has faced skepticism. When Magellan set out to circumnavigate the globe, many believed he would sail off the edge of the world. When the Wright brothers built their first airplane, experts dismissed the idea of powered flight. When Kennedy declared that we would go to the moon, it seemed impossible, but we did it, not because it was easy, but because we refused to accept limits. The first human interstellar mission may not happen in our lifetime, but what we do today, the technologies we develop, the decisions we make, the dreams we choose to chase, will determine whether our descendants will one day step onto a new world, under an alien sky, and look back at our tiny blue planet as nothing more than the place where their ancestors began. So now the question is no longer, will we go? The real question is, who will be the ones to take the first step? Maybe. Say it's someone watching this video right now. If you've enjoyed this journey into the mysteries of the cosmos, don't stop here. Like this video, share it with others who dream of the stars, and tell us in the comments. Do you think humans will ever leave the solar system? And if so, when? Because every great journey begins with a single step. And today, you took that step with us. Until next time, keep looking up.